Alright, time for another draftphysics.com, debatephysics.com. I did say draft physics, right? Yeah. Anyway, video presentation. So still arguing levers. So I thought I could try again, okay, to illustrate the point. Alright, so I'm going to use a 4-to-1 ratio, okay, so 4 to 1. A 1 mass versus a 4 mass. Because frankly, that's how this all started. They claim, Leibniz claimed, that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. Those two things don't have the same momentum. 1 pound dropped 4 feet only goes twice the velocity, and it only has half the momentum when it hits the ground. Something moving that fast. Doesn't matter hitting the ground or not. 1 pound going 1 velocity, 4 pounds going 1 velocity, and 1 pound going 4 velocity, those things equal each other. 1 pound going 2 velocity is not the same momentum. So anyway, so let's say I have the lever in this position. So the 1 is 4 units of distance from the pivot, and there's no counterbalancing weight. All right. So I put the 4 mass here, okay. Now, what's going to happen, right? The lever is going to swing down, and those things are going to be stated to be equal. It's going to clearly say that. And so if I just reverse it, all right. Oh, yeah, it doesn't erase as well. Well, trying something different is always a little bit different. It's always a little dangerous. Yes, it doesn't erase as well at all. Anyway, so let's just do it again. Okay, and this time the 4 mass is here, and I'm just going to put a 1 mass 4 distances away, and what's going to happen? Well, it's going to swing down and balance, so it's going to prove that it has the energy to lift that. Now, the 1 mass at 2 distances, that is going 2 velocity, has no chance. There's no chance. It's a nice smear anyway. I gotta say, smear is very nice. It's too bad it doesn't write as nice as it smears. Anyway, so that's not going to work. A 1 mass at 2 distances is not going to lift the 4 mass at 1 distance. It's not going to happen. Clearly indicating they're not the same, and that you need a 1 mass at 4 velocity to be the same power or energy or force or whatever you want to call it, capacity, quantity of motion, energy. All right, so that's one way of illustrating it. I think that's kind of just proves the point. So in the experiment being argued, let's forget about spaceships and all this other nonsense and just concede that we're just going to drop something with a certain force. And the simple argument is, if I put the same something there at the same distance, I have every expectation that it's going to do exactly the same thing in the opposite direction. Now, first, this proves that direction doesn't matter, right? So all this talk about how it's a vector and all this other crap doesn't really mean anything, because clearly I can switch directions. I can make something go in a new direction for free. And that's especially proven by the idea of just rotating things on a pivot and then releasing them. We know that I can release them in any direction I choose. So I spin it, and then I can just say, hit a button, and I can shoot it that way or I can shoot it that way. It doesn't make any difference at all. So the direction is not a plus and minus circumstance. And clearly the lever's proving it by switching the direction entirely for free. There's no loss of energy anywhere. I get out what I put in, and I just switch the direction. So this idea that somehow, if I have an object and I throw something at it with a mass and a velocity, an mv, and it bounces back, okay, do I really think that it's bouncing back because it did some sort of energy exchange? Or am I understanding that, yeah, it's just basically a lever inside the substance that's basically rejecting the energy and just saying, I'm going to throw it back at you. And then if I make it stick, then it moves the object and it absorbs the energy. So if I'm getting something back, it's not energy that went in. It's energy that's coming back because it was rejected by the object. The object says, I can't absorb that energy, so here, you can have it back again. Now, if I put Velcro here and make it stick, then I'm going to absorb the momentum. I'm going to spread it over my new mass. So I've increased my mass and my velocity will proportionally decrease. And it makes perfectly good sense. And so these are the simple arguments being argued, and they're telling us that somehow if I throw something and it bounces back, that is, I get all my energy back. You know, it swings all the way back in a pendulum, for example. Right? I throw it in, it bounces, and comes all the way back. I get 100%. I'm back exactly where I started. Same potential energy as I started with. And they're going to tell us that there's 2 times the energy, 2 times the momentum in the thing I hit. When, how can it possibly be 2 times the energy of the thing I hit? I got all my energy back. I'm back to the original condition. How could this be possible? How can you possibly think I can put energy into something and I can restore myself to my original condition? That's what they're arguing, and I have to spend 10 years and a million videos saying that's a paradox. That doesn't make any sense at all. How can you argue that? So I'll just draw it out one more time, just because that's probably the best example. Ugh. Need a little cleaner. Alright, yes, I should pause, but, you know, I should do lots of things. Yeah, that's the, you know, oh, that doesn't even work. Ugh, this marker is a little sloppier. Oh, anyway. So again, this is their argument. So I have a surface, a substance, and it has a large mass. And so I have 2 circumstances. I'm going to throw a ball where there's Velcro, and I'm not going to throw a ball where there's no Velcro. Same ball, same idea. And again, it's on a pendulum. So the idea is I'm just letting it go, and I'm going to get exactly the energy, my energy back. So it hits, and it reflects right back again. Okay, totally elastic. The steel says no, and it rejects it. Now they're arguing that I now have 2x whatever this momentum was. If this was 100, I now have 200 momentums somehow in this surface. I move the whole earth, whatever the bullshit is, frankly. Alright, and then if I do the same thing, okay, over here, and it sticks, I don't get anything back. So I haven't restored my condition at all. I've lost everything. Nothing comes back. I got nothing. So I lost, the 100 is gone. Just doesn't exist anymore. And there's only 100 in this. So how does those circumstances make sense? We know the 100's there. We know because it's stuck. It has now, the big mass has now absorbed the energy, whether it likes it or not. It has absorbed it. It didn't come out anywhere else. There's no deformations, there's no sparks, there's no pieces flying anywhere. It's stuck to the surface. There's no heat. So there has to be some explanation. Now, there really can't be an explanation, right? Because it's nonsense. It just can't be that that's how it actually works. But I can't believe how... It's very smeary. You can't see it, but it's really annoyingly smeared. So again, we can go back to 2 steel balls, and the fact is that you know, you can smash them into each other and create a lot of heat because neither one moves. So if I smash them in and I don't allow them to bounce, then they'll actually burn a piece of paper. I mean, they can actually start a fire this way. You know, if you're stuck. You can take two hard objects and smash them into each other really hard, and you will create a substantial amount of heat because the energy doesn't have anywhere to go. It can't move the objects. It wants to, but it can't. And so it has to be dissipated as heat. But I could do the same exact energy and I allow them to bounce, no heat. You won't burn the paper. two objects will bounce. They're free to take away the energy, and you don't have a problem. So, I mean, this, is this really a debatable subject? Is there really some room for a reasonable disagreement, or is it just unreasonable? That, I can keep talking about it, and I'll just keep defending this unreasonable proposition. And so the theory really has to be taken to its conclusion. I mean, its conclusion is a violation of the law of the lever, a violation of Hooke's law, and, frankly, momentum conservation. And you can't violate conservation of momentum. All right, so there was some other thing I wanted to illustrate. So again, their argument is, okay, if I was to, do this lever thing and then drop a lighter object, okay, going the higher velocity, so it's a 1 mass, and I'm going to drop it at a 4 velocity, that it will not, okay, be able to move the 4 mass, okay, at 1 velocity. It won't be able to, because, well, yeah, there's no reason why it shouldn't. So it will be able to, and vice versa. The vice versa is the one they say can't happen. So the 1 mass going 4 velocity, I think, it's a certainty it's going to be able to move that one at 1 velocity. And it's also a certainty that it works the other way around. But their argument is that it doesn't, that somehow the lever fails. So, if I drop this here, and I have the 1 mass 4 distances away, their argument is that this can't be moved at twice the velocity. 4 times the velocity. So even though it's 4 units of distance away, it won't move at 4 units of velocity. And the whole argument I'm making is that it will, because the lever is going to move exactly the same. Because the lever considers the 4 pounds at 1 distance the same weight as the 1 mass at 4 distances. That's the law of the lever, and they're saying that law doesn't apply. That somehow it will balance with this on there, but somehow when you try to launch it, it will catastrophically fail, and you'll need to do this twice. Okay, you'll have to do this twice to be able, that is, you'll have to double the mass or double the velocity to get this to move at 4 velocity, for the lever to move the same exact way. So the simple argument is when this crashes in, when the 4 mass is over here, this and this, well, I should move the fulcrum over here. Yeah, but you get it. Should just use the other pen, Gary. Okay, I'll just use the other pen. Should be clearer. Probably won't write over the goop this thing left behind. Probably won't. All right. So their argument is, again, so the argument is very simple. This dropped is going to move the lever exactly the same if this weight is here or if the 1 mass is here. The lever will move exactly the same. The speed of the lever will be exactly the same. So the acceleration is going to be, the deceleration of this object will be exactly the same for launching this at 1 velocity and launching this at 4 velocity. This side of the lever will move exactly the same speed to do those two things. So you've got to understand, if it's decelerating at exactly the same rate, it has to be the same energy. All right, now we don't have any great experiments, but we do have, again, the Brozosian experiment. And this is, it's just not, it's not that challenging an experiment, and physics really should do it. So the whole argument is Steve Mould, or one of these people with high-speed cameras and all this precision crap, they could do this simple experiment. So you just put a constant, force over here. So you use a consistent spring. And what you're basically going to do is just pull the lever back, all right, and you're just going to have a little notch here and a notch here to hold your objects. And you put the 4 mass there. And then 4 units of distance, you put your 1 mass. So you have a 4 mass going 1 velocity, and you'll have a 1 mass going 4 velocity. And the fact is, it's those two things, the same compression of the spring will produce both of those outcomes. And another test you could do to really prove the point is to do the experiment with one object on the thing, and then you do the experiment with this object, and then you put them both on, and you see if what spring compression is required to launch both of them at the same time. Because you know when you launch both of them at the same time, you're guaranteed to get your 4 velocity here and your 1 velocity here. So it's a guarantee that this will move 4 times as fast. Guaranteed. So there's no bullshit. And the simple truth will be is it'll be exactly twice the spring compression. It's not going to take 4 times the energy or any extra energy. It's only going to take twice the energy because these two things are the same event. All right. Now, the other arguments, I've made them over and over. There's all kinds of different tests, crashing cars, ballistic pendulums. All of these indicate the same truth. And, in the Steve Mould video, Minute Physics basically proved the point that you could just use the pulleys, and you're going to be able to acquire the same result. Okay. Let's see, did I draw that right? This one's connected to that. Well, it doesn't matter. But you're pulling on. This is a pulley. Yeah, that's why it doesn't look right. It's because you did a bad job drawing the pulley. And you're pulling this rope over here. Okay. So, so you just do the pulley thing, and it's clear that the half mass with the same force, okay, same force you'll be fighting, the same pressure, you pull the rope the same way, and the half mass will go twice the velocity. Not 1.4, it will go twice the velocity. So pulleys do it. If pulleys conserve the momentum, you know that levers must conserve the momentum. Come on, it's just not possible for the truth to be invisible to the pulleys and somehow visible to the lever. Right? They're both telling you the truth, and we just haven't done the lever experiment, and they have done the pulley experiment, and that's probably the only difference here. So pulleys tell you, okay, the law of the pulley, you could argue, that you can't get around it. There's no rule saying it's harder to move a half mass twice the velocity, equaling a full mass going 1 velocity. Creating the same momentum requires the same work. The same momentum can never require more work to create. So if you're going to create something that has identical momentums, one of them can't require more work to produce. I mean, that's a pretty simple argument. All right, so I guess that'll be it for the lesson part. I'll see if I can think of any other examples that I need to. I mean, I'm just not going to, doing them over and over again. But you have to do them over and over again because they won't acknowledge the existence of the experiments that do exist, and they won't counter them with any kind of argument. So until they counter them, all you can do is keep saying, please counter the argument. But they won't. They won't draw it and explain where I made a mistake. All right, so Paul Nord has responded, but there's no continuity to the conversation at all. So let's just be clear. He is actually saying that if I was to create this situation, 1 mass is on the outside, 4 masses on the inside, 4 units of distance versus the 1 unit of distance, that this one, even though it's exactly the same angular momentum, so if I was to rotate them at the same speed and calculate the angular momentum, they both have exactly the same angular momentum, and yet he says this one's twice as hard to move, and that this one will do twice the work. And the argument is this is a pretty simple experiment. Why don't you prove that? Because I have no reason to believe it. Nothing I've ever experienced indicates that's true. That if I put a drill on these two things and turn them that somehow I'm going to use twice the amperage, twice the wattage to move this one as I am to move this one. And it's just not going to be true. Now, they obviously, to lift them or to carry them somewhere, yeah, this one weighs 8 plus the weight of the disc, and this one only weighs 2. So yeah, they have completely different weights, but we're just talking about moving those weights. We're not talking about lifting them or holding them or doing any of that. We're just talking about moving them. And it's just not true that this one would take twice the energy. There's just zero evidence. And so again, we're all the way back to, 25 times, the force, the fuel, to do 5 times the velocity. That's their theory. That somehow it takes 25 times the wattage to spin something 5 times as fast. And of course it doesn't. And they should have evidence. If they're going to claim it, they should be able to show me a real experiment really doing that. Or showing something going 5 times as fast doing 25 times the damage. So show something going 10 miles an hour, 10 velocity, and then show something going 50 velocity, and show that the one going 50 can do 25 times the work. Because it won't. It'll do 5 times. 5 times is a lot, but that's all it's going to do is 5 times the work. Because all it has is 5 times the momentum. And momentum is the only thing you can exchange. That's Newton's second law. Momentum is exchanged. Twice the force, twice the velocity. 3 times the force, 3 times the velocity. Momentum is exchanged. Force is momentum. Yeah. Alright. So I'll read his comment and my response, and then maybe I'll see if there's any other comments worth responding to. Alright, back. So here's Paul's response. So I posted the video, apparently he watched it, where I pointed out the craziness of this idea. That's the right way to point. Yeah, that it doesn't take twice the energy to spin the object with the masses further out, that it's the same angular momentum, and it can't take more energy to create the same momentum. Alright, anyway. So he says, okay, if we continue Steve's other thought experiment, so this is, well, anyway, and consider 2 equal masses which are equal distances from the axis moving at 1 meter per second, we get this. And so he spells out the, you drop a 2 on this side and a 2 gets raised on the other side. Not a big surprise. Alright, so he says in this case the total momentum still adds to 0, which again, this is what physics does, and it's just nonsense. There's not 0 momentum in the system. It's just silly to say there's 0 momentum. I have in the universe an object moving, a 2 mass moving with a velocity. After the experiment, I have a 2 mass moving with a velocity, and all I've changed is the direction. I have no 0 amount of momentum. Okay. But now the total energy is 4 joules, not 6 joules. Again, he's calculating the total energy as what? The total energy is just one event. The same energy went in, the same energy came out. So I don't even understand how he could possibly calculate some different amount of energy. The same energy went in, the same energy has to come out. That's conservation. He's saying both are conserved. How is anything conserved with that statement? You have a certain number of joules going in, you have to have the same joules coming out. This is at the heart of Steve's mistake. So he's calling it Steve's mistake when Steve is saying, okay, that yes, it's 1.4, it can't do it, it can't move it. So he's agreeing with him, and yet he's saying this is the heart of Steve's mistake. There's no mistake. You agree with Steve. It's 1.4. It can't move the light mass twice the velocity without extra energy being put in. It will take, so he says, it will take more energy to spin up the balanced lever when one of the masses is twice the distance from the end and half the mass of the other. So he's saying it overtly, okay, that somehow when it's oscillating, there's more energy on one side than there is the other. That somehow the oscillator is fundamentally different when it's the one mass, the two mass moving one velocity, or the one mass moving two velocity. And it's there's no evidence of it, so that's the clear thing. All right, his mistake is about the 5-minute mark in the video. He claimed, look, the first half of the video he was defending an intuition that he proved to be, he claimed he proved wrong, when he didn't prove anything except scientists don't like evidence. He claimed that the rocket would have the same experience. Yeah, he was saying theoretically that's what makes sense, is that, okay, the law of the lever works, momentum is conserved, and then he proved, or stated he proved otherwise somewhere. Obviously he didn't even do the experiment, so we know there's no proof, okay, and therefore the same acceleration. So you just didn't get what he did in that video at all then, right? I mean, did you watch the video? He described his impression, just looking at it, saying, what does it look like it should do? And then he explained how, oh yeah, it doesn't do what it looks like it should do. And the important fact is he's debunking the law of the lever. He's saying Archimedes was wrong, Newton was wrong, and Galileo was wrong, that the momentum is not conserved. Damn. I mean, this is so tedious. Anyway, it's a little more obvious if you try to look at the amount of energy input required to spin up a system when the mass is on each end of the lever. Yeah, I'd say go ahead, show me this spin-up argument. Show me how it's more work to push the lighter things. Show me. Show me that I can't throw a half-mass baseball twice as far. Show me. All right, he has no mass at the near end. But it's a little tricky with our arms are only capable of moving a certain speed, so it's hard to increase velocity because we have to move our whole arm at the extra velocity. He has no mass at the near end, but using a leverage, we certainly can. So if we were playing pili or something and we were extending our arm with a device, it would be certainly easy to achieve twice the velocity with the same effort. He has no mass at the near end, so you only have the force of the rocket on the lever. So again, this is just more nonsense, that somehow the rocket does twice the work to move the lever twice as fast in 1/2 the time, which it can't do. The rocket is not capable of increasing how much energy it's outputting over time, so it can't put on extra thrusters or something. It doesn't have extra rocket engine power. There's a mechanical disadvantage here. So again, he says there's no evidence of it at all. So that's that's the crux of the argument. He's saying he believes that the object with the masses further out is harder to move. The lighter masses further out on a wheel makes the wheel harder to turn. That a tire, where I put lead weights on the wheel, if I put the lighter weights further out, or I have heavy weights on the inside, that somehow the wheel is harder to turn if I have the lighter ones on the outside. The force on the end of the longer lever end, so there's really no longer lever, with the half mass will be 1/2 the force. So again, says him, it's not half the force. The lever is going to move identically to the way it moved with the equal masses. It's not going to change how fast the lever moves. And the time it takes to accelerate will be longer. Well, it won't be, so you're just making claims. Then the time it takes to accelerate the other system. Hand-wavy explanation. So I really hate this, whatever this stupid hand-wavy explanation, hand-wavy term, whatever the fuck that means. All of physics is unevidenced talk. Okay, I don't even know what this hand-waving thing means. What's your point? You can say things without evidence. If somebody else says something without evidence, it's hand waving somehow. The same rocket firing for longer will use more energy. Well, says you, it has to fire longer. So show me the experiment where that's demonstrated. All right, so I responded, it will take, so I'm quoting him, it will take more energy to spin up the balance lever when one of the masses is twice the distance from the end and half the mass of the other. So he's basically saying a one mass outside and a two mass on the inside, on the other side of the fulcrum, that lever is harder to spin than a 2 and 2. All right, this is where I say, says you. This isn't any different than saying 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. Without any physical experimental evidence, this isn't a scientific statement. You're telling me you have a good reason to believe it's true. I'm asking to see your good reason. My good reason to disbelieve is the law of the lever itself. And as stated, the law of the lever is a law of conservation of momentum. Damn it. Not conservation of kinetic energy. And you can't conserve both. How many times do I have to say that? The fact that they won't even acknowledge that there's no way to conserve both. And as I stated in Steve's video, Minute Physics concedes that using pulleys, the half mass will move twice the velocity with the same force applied. Of course, there are other experiments like ballistic pendulums, crashing cars, moving rockets, and tug-of-wars that demonstrate no conservation of kinetic energy. The theory you're defending says it takes 25 times the energy to spin something 5 times as fast. You're telling me you have great confidence that is true. So that's a question I'm asking him. You're telling me you have great confidence that that is true, that it takes 25 times the energy to spin something 5 times as fast. On its face, just impossible for me to believe when I haven't seen anything like that anywhere in my life experience. All right. So there's not much else you can say except yeah, it's just bullshit. All right, so I'll see if there's some other. The comments on my videos are pretty thin, so I'll see if there's anything worth reading. All right, so comment. So by some random gibberish screen name, whatever, KOOPOPTTTO3. Please understand, when Walter Lewin says momentum, he means momentum in the Newtonian sense. So there's only one meaning for momentum. It's mass times velocity. There's no other definition of it. No one's arguing any other definition of it. So this is just absolute bullshit. Okay, which is different from your momentum. It's not different in any way whatsoever. The actual MV is no different. Now, some concept that you can have positive momentum and negative momentum, that's worth arguing, fine. I'm saying if Newton believed that, then he wouldn't have written a third law. If he believed it, he wouldn't have said twice the force, twice the energy, velocity, 3 times the force, 3 times the velocity. And he certainly would have pointed out that you can make free momentum, because that's obviously the consequence of it. So bullshit on you. Fuck you. This is just such horse shit. Debunk something I've said in the damn videos, okay? I'm giving all these illustrations. You show me a piece of evidence. Don't keep telling me what Newton said, because you're all lying, slandering assholes, frankly. You have no respect for Isaac Newton. So, fuck you. Try again. Never. All right, let's see. So this Kate person says, on a video not on the goddamn subject, of course. Hello, can you please break down a video called The Shocking Discoveries a Voyager Made on the Edge of the Solar System, blah, 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 blah. Okay, I would absolutely be fascinated to hear. Yes, you're fascinated. I'm completely unfascinated. Voyager was made in the 70s, okay? It's not exactly high technology instrumentation. So when it's flying around billions of miles away, okay, being 50 years old, it's pretty silly to sit there and take anything it sees too seriously, because it doesn't see with very good eyes. Frankly, they shut the cameras off. Okay, their capacity to detect how many molecules they're crashing into is really dependent on how many hit them. Okay, they can't really detect how many molecules are actually floating in space if they don't have any momentum. So the whole thing is a little ridiculous for you to take it all too seriously. But it doesn't really mean anything. What do you think it means? That there might be different densities of matter in space? That, you might go from 1 part in a billion to 3 parts in a billion? That there'd be places where there might be more hydrogen atoms than there's other places to be less hydrogen atoms? You think that's a huge surprise? Well, I don't think it is. And you think as you're traveling, you might be seeing the universe differently, which means you might be going into a packet where some gamma rays are hitting you from some source, okay, that you weren't interacting with until you fly to that location. I mean, there's rays and beams going all through the universe. So it's hardly big news. But whatever, be fascinated by whatever the fuck you want. I don't give a damn. I obviously don't give a shit about any of this crap about what the fucking universe is doing. The real universe is electrons and protons. That's the real universe. The electrons and protons interacting in empty space with a force. That's the real universe. That's the only universe. Shit. Hello, I'd like to... So this is Lord Zeno. yeah, you're a lord. Oh, God damn, Lord of the Maggots. Hello, I'd like to counter the free momentum in a direction argument. Well, you really can't. I mean, that's their theory, that you can make free momentum in a direction. What's your counter argument? It's not free momentum. It's more momentum in a direction, but it's not somehow extra momentum in a direction. It's only more momentum, not extra. In the Newton's cradle 3-to-1 ratio of collision, you predict the ball will reflect with 1/4 of the initial velocity. Yeah, I'm saying that's absolutely true, yes. Let's say we have a 1 kilogram coming in at 10 meters per second, so the initial momentum is 10, but collides with 3. According to your model, the 1 kilogram reflects with 2.5 meters per second, so the momentum is 2.5. Okay, and the 3 ball continues with 2.5, so the momentum is 7.5. Right, so you still have 10. So how are you going to fix that? This means that although the initial momentum was 10, the 1 kilogram only transferred 7.5. Yes, that's exactly the point. It's small objects going fast can't move big objects and give them all of their energy. That's why there's a reflection, is because the big thing can't go fast, so it has to convert. And every time there's a conversion, every time you have to convert a big M into a small v and a small m into a big V, the conversion, okay, takes time. And these are things happening in too quick an amount of time. There's not enough time for the conversion. The contact doesn't last long enough. All right, transferred to the 1 kilogram continues, but wasn't transferred. However, the 1 kilogram's direction reverses. Yes, just like in a lever, the direction reverses, and it doesn't mean a damn thing. It doesn't consume any. You don't have to consume any energy to reverse direction of motion. That's what the lever proves. Alright, in order for direction reversal to take place, the 1 kilogram must first transfer all of its momentum to the... No, it mustn't. So lie some more. That's like saying the brick wall has to you throw the tennis ball has to convert all of its energy into the brick wall and then wait for the brick wall to give it back. No, duh. The tennis ball is the thing deforming. The tennis ball is the thing converting the energy. And it finds it can't put any into the wall and then bounces back. Moron. Alright. If it still has momentum that wasn't transferred, it won't reverse its direction. So he says, if it still has momentum that wasn't transferred, it won't reverse direction. How can it do both? It can't be reversing and then you say it will reverse. It either sticks and gives its energy to the object and dulls the reflection, or it reflects. It can't do both. It can't give its energy and reflect, obviously. I can't get my energy back. You can't understand that if I'm getting the energy back, it can't be in the object it hit? God, you're so damn stupid. Rather, it will still continue in the same direction as before the collision. In reality, the small ball always bounces back in the opposite direction. Says you. Says fucking you. If I throw a ball at a piece of cardboard, the cardboard moves, the ball doesn't bounce back. Why does the ball not bounce back when I threw it at cardboard? Well, it's because the cardboard absorbed the energy, obviously. Oh, god damn, these people are dumb. Alright, here's a step-by-step explanation of what happens according to conventional science. You don't have any evidence of this crap, so I don't need this crap. Okay, you're going to sit there and tell me that you made twice the momentum in the universe. I have 100, I throw it at something, now I have 300. No, I don't. Alright, so, yeah, there's no bother. The 3 mass originally had 0 momentum. See, this is the waste of time. It gains exactly 15 momentums. Right, so more momentums than I started with. I started with 10, now I have a 3 mass of 15. And you're debunking my argument? No, you're making my argument for me. That's free momentum, that's free energy. I can make the free energy machine with that extra energy. You can't make extra momentum and then claim that's not extra energy. It's just idiotic and ludicrous. Alright, why is it not a violation of conservation of momentum? Yeah, free momentum is a violation. The total system momentum is still the same. So the system, they're pretending that this way is minus and this way is plus. So if I make it the other way around, I say this way is minus and that way is plus, well then I'm down 100 and I've somehow created negative momentum in the universe. I now have a negative energy in the universe. What a pile of shit. Alright. I mean, it's just so goddamn stupid. Alright. The momentum gained by the 3 mass plus 15 is exactly equal to the momentum lost by the 1 mass minus 15. Minus 15. So they're just saying because it changed direction, it's complete negative. So in the lever example, I put the 2 mass in this way, I have plus 10 momentums, and then when this one shoots out with 10 negative momentums, okay, that somehow makes sense to them. That I had 100 momentums and I destroyed it because now there's 0 momentum. Obviously there's not 0. Obviously. Oh god, these people are stupid. Imagine you are running towards a wall at 10 meters per second and then you bounce backward at 5 meters per second. You just don't stop, you reverse direction. So it doesn't even make sense. Obviously I'm not elastic. I'm going to crush, I'm not going to bounce. To do that, you had to not just lose 10 meters per second, but also gain an extra 5 meters per second. The total change was 15. So again, it just keeps doing the same stuff. Well, obviously your debunk has completely failed to deal with the fact that I can make, using your theory, I can make a free energy machine. I already drew it 14 times now. Okay, argue that illustration. You keep getting your 100 back for free and putting 200 into the object. That's free energy, shithead. God, you people are just so damn stupid. Alright, so surprisingly, Dr. Julian Newman's channel didn't respond. I left 2 comments, so maybe he didn't see them because I did notice that, you know, it's my own video. He commented on it. I replied, and YouTube doesn't show my replies unless you hit the newest first button. Now what the fuck is that? It's my own video and it won't let me reply to a comment on my own video and actually show it. I mean, ugh, what fucking bullshit. Why do they get away with this comment segregating thing they're doing? This idea that somehow some comments aren't worthy. It's like email. I can't use my domain email because every institution blocks it. Now, no one's ever spammed from any of my domain names. Why are they on a spam list when they've never spammed anybody ever? I've like sent 100 emails a year. 100. That's it. I mean, it's the whole internet is just such a racket. All right, till the next time and such. Probably, I'll see. Do a pause and see if there's any last statements to make to these assholes. Oh, yeah, I just saw a jerky comment. Sound like somebody is jealous of other people's popularity. Yeah, right. I've been doing this for 10 years out of jealousy. Yeah, fuck you. Just such pathetic arguments. Let's see, I think I get it. So you don't debunk science, but you explain it better. So, I mean, clearly every one of my videos is a debunk. Are you retarded? Oh, there's no point in asking, right? Oh, fuck. I mean, the whole fucking world ought to be just declared incompetent. You people really can't do logic and reasoning. Let's see, some other asshole. Usually academia facts are just agreed upon compromise. Compromise? Is that scientific? Hell no. I don't think it's a compromise. They just say, okay, I don't have any better argument, so go ahead, we'll believe in Trixie the Wonder Frog. You know, I mean, somebody comes up with some dopey explanation. Everybody else says, I don't know. It's too complicated for me. And so they just agree to the other asshole's bullshit statements. Alright. Let's see. Yes, Newton used pendulums, and what was it that he found out? Twice. Okay, twice the force, twice the velocity. 3 times the force, 3 times the velocity. That's what he found out, fuckhead. Oh, God. Such crap. So, that's probably enough. I'll just get the hell out of here. God, I hate it on this planet. You people are just way too fucking stupid.